Hi, I'm Rob Kellogg, and today we're going to talk a little bit about ground fault circuit interrupters, how they work, and what our responsibilities are to utilize them when we're using electrical energy for our work processes. So first and foremost, we need to understand that ground fault circuit interrupters are a leak detector. Now you also have a mechanism called a circuit breaker. Those are energy volume protectors. So we don't want to get too much energy through the system that can't handle it, causing an overload. But ground fault circuit interrupters are a leak detector to the circuit that allow you not to get electrocuted. So it's a safety feature that in case you become the ground mechanism with the energy flowing through your body back to the source, the ground fault circuit interrupter will actually identify that loss of energy and therefore shut it down. So kind of to demonstrate how that works and some of the things that you need to do in order to make sure it is working, let's cover that now. So when we're talking about a ground fault circuit interrupter, we're going to have two sensors in here. You have your hot line, the black line coming into the ground fault circuit interrupter, and it goes out to your tool. This is all coming from the generator, wherever that energy source is coming from, whether it's the generator out back or if you're plugged into the utility systems that we normally use. But once it goes from the generator through the sensor identifies how many amps actually are needed by the tool demand as it's pushed through or pulled through. And once the tool uses it, then it goes back up through the Gfci again through another sensor, and it identifies how much energy actually came back from the actual tool after it's used. And it goes back to the generator, back to home. Normal electrical circuit. Now if these two are equal, there's no problem. The circuit stays closed and energy flows. But for some reason, past your ground fault circuit interrupter, past that line on either one, if we have a leak of some kind, whether it's through insulation mechanisms, there's actually a grounding mechanism happening, there is a phase-to-phase event going on, then this sensor here will identify those differences within milliamps, very small, minute changes, and in milliseconds. And the process really works is, if I've got a 120 volt system that I'm utilizing, normally what I'll utilize for most of my tools, we use normally about a 20 amp system and potentially can get into 30 amps, but again, that gets into specialty stuff. But our normal operating energy is a 120 volt, 40 amp system. Now, the voltage is AC, which is alternating current, not direct current like from a battery. But alternating current has a wave of energy that goes up and down. And within 60 seconds, you will have, within 1 second, you'll have 60 varying alternating current waves go through the energy source. So starting with the first wave, the energy goes through the sensor and identifies how much amperage is going through it. As it goes to the tool and it gets utilized and back to your second sensor, actually within the third cycle of a 60 cycle per second system that we're normally using, it will identify that there's a change in current, a change in current that's dropped off on either the hot side or the neutral side, and it will open the circuit, causing the energy to stop the flow within that time frame. So from here to here, 60 alterations, and this is 1 second. That's a lot of up and down that you'll find within the circuit in a very short period of time. This is why we don't feel electrical current going through our bodies when a ground fault circuit interrupter is utilized, because it takes resistance of our tissues to generate a heat source in which our nerves will actually sense that heat, causing that energy to go to our brain and to identify. Within 3 cycles of a 60 cycle second, basically in a second, you're talking milliseconds, you won't even develop enough energy to develop that heat source and you won't even feel it, which is really the purpose of ground fault circuit interrupter. It's to help you from getting hurt from the electricity that's leaked out of the current system and therefore you don't become part of that system. And if you do, it prevents you from feeling it. So we want to make sure that before each shift, we go in and there's always that button in between that you'll see on your ground fault. You'll have a test button, and then you will have a reset. So what you do, simply hit the test, it kills the energy, you go back and reset it, test your tool, it should work, you're good to go. So test your tool, hit the reset, test the tool to make sure it's working, your ground fault circuit interrupter is functional. And this should be done every single day before you use it, every single day. So take good care of your GFCIs, ground fault circuit interrupters. They're there to help you, assist you, and keep you safe. And they're also help you keep your tools from getting overcharged as well and causing internal damage, meaning you got to replace them. So, as always, if you have any questions, please contact us here, and we're here to help you at any moment we can. So remember, safety is not a mindset, it's a state of mind. Have a good day.